All right, so we're going to continue this lesson next, looking at absolute value inequalities. Okay, so there are two that we're going to look at. First one being the absolute value of x is less than, or like if you want, we can put less than or equal to, because both statements are going to look the same. Okay, that's going to be equivalent to, again, if we take the process that we use for solving absolute value equations and use it for absolute value inequalities, you can say that the two possibilities for what's inside the absolute value bars is, number one, that's what's inside the absolute value bars is positive. So if that's the case, the absolute value of x is going to be less than or equal to a. And, okay, so you're going to separate that with and. The second possibility is what's inside the absolute value bars is negative. And if we're taking the absolute value of something that's negative, we're going to take the opposite of that quantity. Okay, so the, negative x is going to be less than or equal to a as well. Now, when I take the second inequality, again, we're going to be solving for x. So when I multiply or divide both sides by -1, then that's going to become x, and then my inequality symbol is going to reverse. So x is going to be greater than or equal to a. And when you combine those two statements, what you're going to wind up getting is, if you rearrange these two inequalities here from smallest to largest, sorry, that should be -a, not a. So when you rearrange those from smallest to largest, the smallest value is a, and that's going to be less than or equal to x, which is going to be less than or equal to a. Sorry, I'm just going to do those in red to show that those are two different statements. Okay? And that right there is going to be your output for that first inequality. All right, when you have the absolute value of x is greater than or equal to a, when you use that same process, that's going to be equivalent to, again, we're going to have two different outputs here. So the first possibility is what's inside the absolute value bars is positive. If that's the case, the absolute value of something that's positive is the expression itself. So we're going to make x greater than a or equal to a. And then you're going to separate that with or. The second possibility is what's inside the absolute value bars is negative. So if we're taking the absolute value of something that's negative, I can rewrite the absolute value of x as -x, which is also greater than or equal to a. And then again, when I take both sides and multiply or divide by -1, that's going to make x, the inequality symbol is going to reverse. So that's less than a or equal to a. And then you can combine these two statements here as, sorry, and that's -a again. So you can combine those two statements to be x is less than or equal to -a, or x is greater than or equal to +a. Okay, so we'll take a look at examples involving both of these. Okay, so directions for all of these ask us to solve the inequality. And for number one, we have the absolute value of 1 minus 4x minus 2 is less than 3. Okay, so our goal, just like with solving absolute value equations, is we want to isolate the absolute value expression. So the way that I can do that is by adding 2 to both sides. So we get the absolute value of 1 minus 4x is going to be less than 5. Okay, so again, when my inequality symbol here is less than, I know I'm going to separate the two statements with and. Okay, so my two possibilities. First one is what's inside the absolute value bars is positive, and if that's the case, the absolute value of 1 minus 4x is just going to be the expression itself, 1 minus 4x, which is less than 5. And the other possibility is what's inside the absolute value bars is negative. So if what's inside the absolute value bars is negative, I'm going to take the opposite of that entire expression. So we get the opposite of 1 minus 4x, which is also going to be less than 5. Okay, so I just want to solve each of these inequalities here for x. So I'm going to go ahead and subtract 1, which gives me negative 4x is less than 4. And then I can divide both sides by negative 4. When I do so, that's going to reverse the inequality symbol. And we get x is greater than negative 1. Okay, when we do the same thing for the other expression, I'm just going to go ahead and distribute the negative across both terms. So that's negative 1 plus 4x is less than 5. I'm going to add 1 to both sides and then divide both sides by 4. 6 over 4 simplifies to 3/2. So we get x is greater than negative 1 and x is less than 3/2. Well, what we can actually do in this particular case is I can combine these two statements here into a single compound inequality where I can say that negative 1 is less than x, which is less than 3/2. If I wanted to graph that solution, it would look like this. We would have negative 1 and then 3/2. We would have open dots at both of those values, and we're looking at all of the values in between those two numbers. If I wanted to write the solution to that inequality in interval notation, that would be the open interval from negative 1 to 3/2. Okay, I'm going to have you guys do the second one. So go ahead and pause the video, get the second one copied, and then whenever you're done, unpause and we'll work on it together. Okay, so again, for number 2, we want to do the same thing we did for number 1. We want to isolate the absolute value expression. So first thing we're going to do is subtract 8. So we get 5 times the absolute value of 3 plus 2x is less than or equal to negative 2. And then we're going to divide by 5. So we get the absolute value of 3 plus 2x is less than or equal to negative 2 over 5. Gosh, I hope you guys didn't work the problem all the way from there. Because if you look closely at what you have, is it possible for an absolute value expression to be less than or equal to a negative number? And the answer is no. Like the smallest the absolute value expression can be is 0, and all the other outputs are going to be positive. Okay, so this right here again is not possible. You can write the solution one of two ways. You can write set braces and put nothing inside of it. Okay, that's the empty set, which means there is no solution to that inequality. Or you can write it 0 with a slash through the number. That means that that's going to have no solution. Okay, so again, just like with the absolute value equations, like you have to look at the inequalities closely and think to yourself, is this something that is even possible for me? If the inequality makes sense, then we go through and solve it just like we did with number 1. If it doesn't make sense, then we say that it has no solution, or it's possible that we can have infinitely many solutions as well. We'll take a look at an example like that in a second. Okay, you guys give problems 3 and 4 a try. So again, get those copied down, work those out on your own, and then whenever you're done with both, go ahead and unpause the video, and then we'll work on both together. All right, so with number 3, we have 7 minus the absolute value of 2x minus 5 is less than or equal to 4. Okay, so again, we want to isolate the absolute value expression. Okay, so I'm going to subtract 7 on both sides first. We get the absolute value, negative the absolute value of 2x minus 5 is less than or equal to negative 3. And then I want to get rid of the negative out in front of the absolute value expression, multiplying or dividing both sides by negative 1. So when I do that, we get the absolute value of 2x minus 5 to be, the inequality symbol is going to reverse when I multiply or divide both sides by a negative number. That's going to be greater than or equal to 3. And that makes sense. It's possible for an absolute value expression to be greater than or equal to 3. Okay, so I'm going to go ahead and work it through from here. So first possibility is what's inside the absolute value bars is positive. If that's the case, I leave the expression alone. So 2x minus 5 is greater than or equal to 3. And then when our sign is greater than or equal to, we're going to separate the two inequalities with the word or. The second possibility is what's inside the absolute value bars is negative. So if we're taking the absolute value of something that's negative, we have to take the opposite of that entire quantity. So the opposite of 2x minus 5 has to be greater than or equal to 3 as well. And then we're just going to go through and solve both of these inequalities. Okay, so when I solve the one on the left for x, I'm going to add 5 to both sides. We get 2x greater than or equal to 8. And when I divide both sides by 2, we get x is greater than or equal to 4. Okay, for the second one, I'm going to distribute negative 1 across both terms. So that's going to make negative 2x plus 5 is greater than or equal to 3. And then I want to solve for x. So I'm going to subtract 5 on both sides. We get negative 2x is greater than or equal to negative 2. And then when I divide both sides by negative 2, the inequality symbol is going to reverse. So x is going to be less than or equal to 1. Okay, now when I rearrange these inequalities from smallest to largest, we're going to get x is less than or equal to 1, or x is greater than or equal to 4. Well, I can graph the solution to that inequality, or to those inequalities, looking like this. So x is less than or equal to 1. It's going to be a closed dot at 1, and the graph is going to extend to the left. X is greater than or equal to 4 is going to be a closed dot at 4, and the graph extends to the right. If I want to write that solution in interval notation, there are two intervals here. The first one is from negative infinity to 1. Because 1 is a solution, we close that part of our interval. So we're going to use a bracket at 1, and then we're going to union that with the interval from 4 to infinity. Again, we have to bracket the value at 4 because 4 is a solution to that second inequality. And again, while I know that whenever we were solving equations, like my process kind of seemed like it was a little bit longer, a little bit more difficult, but I actually think for solving inequalities, it makes the process a lot easier. And I just like doing it that way because I can use the same process for both. Okay, let's take a look at 4. So if you look at 4 is the same problem that we had in number 2. I just flipped the inequality sign. Okay, so we have 5 times the absolute value of 3 plus 2x plus 8 is greater than or equal to 6. So again, I want to isolate the absolute value function. So I'm going to subtract 8 on both sides. So that's greater than or equal to negative 2. When I divide by 5, we get the absolute value of 3 plus 2x to be greater than or equal to negative 2 over 5. Well, again, let's look at this inequality and see what makes sense for us here. Again, we know for an absolute value function, either the outputs are going to be 0 or the outputs have to be positive. Well, isn't 0 or any positive number always going to be greater than or equal to negative 2/5? So if that's the case, there are 2 ways for us to write solutions. Like any real number is going to be a solution. So we can write our solutions as the set of x. This bar means such that x is an element of the set of real numbers. Okay, that's what it would look like in set notation. I think we're probably going to want to write our answers in interval notation. So the way we would write all real numbers in interval notation is the open interval from negative infinity to infinity. Okay, so that means that all real numbers are solutions. Okay, so again, make sure you look at your equation and inequality closely. Like you don't want to have to be doing like unnecessary wrong work when solving your equations or inequalities. Does it make sense for me to solve the equation or solve the inequality? If it does, then work it through. If it doesn't, then your answer is either going to be, no solution or all real numbers as a solution, depending on what your equation or inequality looks like. Okay? All right, so that'll be your first lesson for the week, and then I'll have this as well as your second homework assignment posted as well. Make sure you guys have this lesson watched and the homework done before we meet for our block synchronous meeting on Wednesday. All right, guys, hope you're doing well. Hope you had a great weekend, and we'll see you tomorrow.